Yeah, so my name is Kasper, and yeah, I'm gonna share some improvements I've done to the Rust SDK, but also a little bit of test scenario or what you want to call it, seeing an actual real world use case of it. So let's begin. And first of all, yeah, the Rust SDK enhancements, and second off, I'll show how I solved one of Rust's core issues that it has with build systems. So that's going to be interesting. Yeah, so in the 0.30 release, the release has really been about reducing boilerplate, reducing cruft, reducing things we didn't need, and putting the Rust SDK in alignment with the other SDKs as well. So they are pretty much compatible in the way they work, and the ideas behind it, of course, still with different syntax and whatnot. Yeah, so the idea is I have this first example here, and here we just have a base application where we start the client, we fetch a directory, and next up we run some arbitrary code. This is just an example, but one of the issues we had in the previous release is the Rust SDK, as opposed to all the others, required this extra bit of cruft here. So you see we have this source directory, so that's the directory you hold on to right now, and you'd like to load into the container to run some sort of an application. Previously, before 0.30, you had to do this dance here where you had to take the ID, you had to await it, and then you can continue on with your operations. The problem is that this really goes against what Rust does, or sorry, what Dagger does. Dagger is best when you give it all the stuff you need, all the graphs, all the things, and just let it resolve it at the end and figure out the best option or the best way to do it to solve the graph. So this is the new version. So the only difference is really here is that you now don't need the extra await question mark. And the question mark here is just to return an error if it fails. So that's really just it. But this helps quite a bit and makes code more easily shareable and all that stuff. So that's very nice. There's a whole bunch of work, much more work than it might seem to support this feature, but yeah, it works. Yeah, and here is a little bit of a graph on what is actually going on here. So here, first of all, we start the client. Next up, we do stuff. This might be in a component, you download from the internet somewhere, in your package manager. It does stuff, load some code, but now it has to wait. Now it actually has to stop, and load this directory, or do something else. It might also be a longer running, for example, pulling a GitHub repository as well. And then it can do some more stuff afterwards, and then finally we actually resolve the client code or resolve the graph at the end. This is a little bit troublesome because now we break down and don't really use the lazy features of Dagger to do what is best at, solving the graph. And here to the right, you'll see the new thing. We can connect and create our client. We can do all the stuff we need. We can do all the computation we need. We can do all the orchestration. We can set up all of our pipelines and whatnot. And then finally here, you don't even need this step. You can just set standard out that await and just let the Dagger do its magic. So that is super nice. Yeah. So again, this is a big deal because we play to the Dagger engine's strength basically, and it's much easier to build components as well, which I'll show in the demo. But yeah, that's pretty much it. Next up here, that was a short part. It's a short feature, but it's very useful for UX. The next part here is more of a showcase. One of the problems is with Rust, and I think I shared this on a previous community call as well, is that Rust is very difficult to get to play well in a CI system. And that is, it's quite easy to build, but it's quite difficult to get it to be performant. And I work as a platform engineer, so one of my core skills is just to optimize pipelines, make them fast, make them reliable, and all that. And Rust makes this quite difficult. The main problem is that to build a project and download dependencies and compile that dependencies, you run a single command. And when you build a Dagger pipeline or Docker pipeline or whatever you'd like to build, you'd like to split this out into multiple parts so that you can cache the fetched dependencies, you can catch the compiled dependencies, and you can, react when the client application code changes. You only have to do that single step afterwards. That's what you really, really want. But Rust really makes it difficult because it doesn't allow you to do that. It only allows you to build it at once. You cannot fetch code initially, and you cannot compile the dependencies without the source code. And that is what I've solved in using Dagger. Yeah, so let's jump straight into the demo. And I've actually also built it as a it's called as a library as well. So that is quite nice. So here I have a package that I use for my own projects. I'll just scroll all the way here to the top. It's quite long. There we go. So what I have here is I have a package called Rust source. And what this allows me to do is it allows me to set up, a preset on how I like to build my projects. It might not be applicable to you or to anybody else that builds Rust, but it's the way I build Rust. And this makes it super easy for me to use. The gist of it is it can load a GitHub repository or a Git repository for that matter. It can fetch out and do some processing that makes Rust very easy to build. There's a bit of craft here, but the idea is basically I load the code, I load the parts that I want. That means I load, kind of like in Golang or in Python, I load the requirements or the go.mod.sum and whatnot. I load the folders and look at what folders I have available, to see what packages I need. And then I do something called skeleton files. So Rust to compile, even though it has this go mod and whatnot, it still needs some very basic main files and lib files. And as such, here I just create some dummy ones. So these are just empty files. I have to scroll down here. That really has nothing in it, but that just panics if you actually try to use them. And I do this in my first step. And then in my next step, I actually load in the actual Rust code and run the build again. So I actually run the same command twice in a row. But the second time is the for realsies build. And it makes it super easy to use. So that's a lot of code, and I won't show that there anymore. But here I actually have a real project. So I have a project here called Churn. It's basically a Ansible thingamathing built in Rust using WebAssembly and all the bells and whistles, buzzwords and whatnot. Very in progress, but I've used Dagger to develop this distributed configuration system. And the way I've done it is I've kind of taken the Lisp approach. I'll get back to the plugin in just a moment, or to the package in just a moment. But I've built kind of a REPL where I can actually orchestrate my stuff in Dagger, let it run, tear it down, test it stuff all the time to make sure my distributed system actually works as I'd like it to. And I'm just going to show it here running first, and hopefully it's cached, because otherwise we're probably going to sit here for a while. So in this application here, we have a few different parts. We have a server that acts like kind of like the host. We have an agent that runs on a separate virtual machine, and then we have the CLI that also runs on itself that can communicate with the master. And here I have a REPL that looks a little bit messed up, but what I can do is I can say, okay. I can bootstrap something and it runs a command, it enrolls an agent, and now the agent now begins to listen to the master. And this is all built using service containers in Dagger. I can also do churn. Oh, it's a little bit messed up because of the service containers, but I can now monitor. And if I monitor, I begin to listen to events. It takes a while, but here you can see the events begin to stream in. And these are the pings from the agents that are calling. And all of this is run, just in this REPL. So when I tear this down, everything's gone, and I can start it back up again. And this is running directly on the source code of the project. You can see it goes by, blah, 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 and it starts up again. And I'll just show the caching working here quite quickly, and I'll show how it actually works in just a moment. Oh, that's not actually what I wanted to change. Do this one, and I'm just going to insert a comment here. It doesn't really matter what it is. It's just I want to simulate, a changed file, and hopefully it won't do the full build, but it should go in and okay, yeah. it was quite fast. So, I changed the source code. It was super fast. It might actually become because I wrote exactly the same as I did during my testing. So I'm just going to add something more. I'm expecting that's the case because it should actually compile something instead of just using the cache. But now you can see it compiles a few files. So it compiles all the top level files that are needed to construct a binary. So it still has some work to do, but it's much less than normal. And do keep in mind, it needs to do it thrice. It needs to do it 3 times, one for the server, one for the agent, and one for the CLI. So it still takes a little bit, but this is a way where I can test an entirely distributed system in just, with a REPL where I can just write the commands and it does it. All right, enough about that. I won't show it build to completion here, but the important part, the interesting part here is actually what makes it run, the entire distributed system. So you can see I connect to the SDK, and I, have a server, I have an agent, and I have a CLI, and they're all bound together by these service bindings. But to actually build the project, I just have a simple function, or simple-ish. It's Rust still, but as simple as it can be in this. And here I have it has a few parameters. But basically, all this requires is this code block here, and now I have built a production grade Rust cached thing, and I can share this using my package manager. And this is actually shared using the package manager. So this is something that would be, if not impossible, very difficult to do with a regular Dagger build. Maybe some other comparable tools could do the same, but this is something a little bit special. And here I can even, if I wanted to, I can even add another image if I'd like. I can even go in and say, I'd maybe like, I don't know, Alpine instead. I think Matthias has felt the pain of using Alpine, so I probably won't. But, I can go and do that and all that jazz. And yeah, I would just have another build. I also have another project, which, let's see if I can find it. I think it's this one here. Where, yeah, it's this one. It looks like it's the same code, but it's actually a different project. And here I actually I can build multitudes of images and publish them in a single step afterwards. So this means, I reduce code sharing, I reduce the templating, I reduce all that stuff across the projects. Yeah. And this package is also available on GitHub, I think, or my own Git instance, but it is at least open source, so you can go and have a look at it. Also the distributor thing if you'd like. Yeah, there isn't much else to it. It's I would say it's quite simple. And just to set up all this REPL here is, what is it? 140 lines of code or something with white spaces. So you can make it quite easy if you'd like. Yeah. And let me just go back to my slides here quick. So just briefly before I end off, I know I'm a little bit early, but the things I'd like to do next for the Rust SDK is to remove the structs that the library depends on right now and generates into something called traits and functions. And this is because right now it's very difficult to move between Rust versions because we have a hard dependency that all the libraries you have need to be on exactly the same versions. And I'd like to make that easier so you can actually, support a range of code instead of everyone having to be on 0.3.1. And exposing raw structs in Rust makes that very difficult, especially with the SDK. Yeah, and that goes into the second part as well. Make version upgrades simpler. My code, which I showed before, is actually still on the old 0.2 point something release because I have to upgrade all my libraries at once to be able to take effect of it. So that's really something I want. And last up, I want to move away from a library called Aya, which is error handling library, to something called this error, because now then you can do pattern matching on errors. It seems like a small thing, but when you have to catch an error, if you would like to handle an error at some point, it's very nice to actually have types that you can depend on. That's really what Rust is. I don't know if there's any questions.
There was some comments. Everyone's very, very excited about all the work, and I want to just express how thankful everyone from the community is around all of these contributions and improvements you've made. It's very appreciated. And then Alex, I think will end up DMing you because he's doing a lot of support on running interactive programs in the Dagger TUI. So this could be useful with the Ripple. So that's great to see all the connections there. Thank you again, Kasper, for your time and just all the work you've done here. Oh, one question from Guillaume. Does your library accept a Git repo with several crates inside?
Yeah, it does. So I'll just quickly show you because that's actually what I'm doing as well. Let me see, churning here. So, I have not a very pretty builder pattern. That's also why I get all these arguments. You could make it as nice as, the Dagger CLI itself. But if I go here down to the bottom, you can see here I have a crates variable. It takes a crates and then a prefix or then a wildcard, and it will do this thing here on all the crates in that folder and the CI here as well. So if I added another crate, oh, I don't know what I did there, but some crates that would automatically be hooked up. Right now it's a little bit opinionated because it only supports a single destination. So that means that, it only builds a single binary, but you could pretty much configure it to whatever you'd like it to be. Yeah. So that's pretty much it.